Ik weet zeker dat onze volgende spreker daar ook inzichten zal over hebben. Dat is Frederik de Kok. Ik ken Frederik al lang. Hij is hier zijn carrière gestart bij FPC Risk, maar heeft dat redelijk snel besloten toen om voor een kleiner bedrijf te kiezen, FM Global. Hij is 47 jaar jong, burgerlijk ingenieur, architect. Is denk ik dit jaar bijna 20 jaar bij FM Global. Dat is heel knap en heel loyaal. Hij is op dit moment loss prevention engineer met een specialisatie in chemical risks. En hij gaat jullie de rol van de verzekeraar toelichten bij de overgang naar Triple F. Dus Frederik, the floor is yours. Succes.
Thank you very much, Ralph. My presentation will be in English because I understood that a couple of our clients overseas have logged in. So welcome people from the US. Good morning to you all. I must say that all the presenters that you have seen so far, we are all in agreement about the same thing. It's a major challenge. What I will present is the challenge through the eyes of an insurance company. Now you would say, why would an insurance company like FM Global, there are many other insurance companies that do property risk, why would they be interested in something like environmentalism? Because let's face it, an insurance company covers buildings, equipment, storage, business. There's nothing human in it. We don't insure the lives of people or the contamination. So why do I say this? Well, FM Global does fire tests. Everybody knows that we have data sheets that provide you with loss prevention information. And we also have a certification body called FM Approvals that gives an approval for the entire world on certain equipment or foams, for instance. But what does that have to do with all the cycle of the PFAS? I think many of the presenters explained it. It's about the PFAS that's, among other contaminations, is in the firefighting foam. It comes into the groundwater because of testing, because of leaks, because of actual fires. And then the groundwater with all the PFAS is sucked up again in plants, in drinking water, and this way it comes into the human body. So why would we be interested in this? Well, let's face it, every company nowadays has the word sustainability, environmental responsibility in its logo, in its teams, and so does FM Global. So we believe that whenever we go on a site, we have to make recommendations or improvements that are robust, resilient. Resilient in Dutch means veerkrachtig. So we have to make recommendations that are also environmentally not robust, I mean. So not something that you have to take out of service in a couple of years because it's harmful for people. That is why FM Global and other insurance companies are interested in the PFAS transition. So where did it all go wrong with firefighting foam? Because PFAS and the PFOAs already existed in the 1940s, but things started turning in the late 60s when an accident happened on an aircraft carrier, where one of the airplanes shot by accident rockets to the ship and caused a major fire. And in those days, firefighting foam was based on proteins, like the fire chief of the Antwerp harbor explained, and it wasn't very efficient. As a matter of fact, 134 people died during that fire. And so the US Navy said, we have to have a foam that is much, much better and can extinguish a fire within 30 seconds. It was developed later on, and it was great because they used one of those forever chemicals that cannot be destroyed. So that's for the mobile firefighting. Now the stationary fire protection systems, which means sprinklers, fixed discharge devices, we're also interested if you could do something with the foam getting through the sprinkler nozzles. And as a matter of fact, through the 90s, developments were made to make sure that you can actually have a proportioner with foam concentrate to inject foam concentrate in the piping and getting a marginal foam out of the sprinklers, but it does the job. Not within the 30 seconds that the US Navy recommends, but we're already happy if the fire is extinguished after 2.5 minutes. It was a major success. Also because it was easy to add on to an existing sprinkler system. Sprinklers are the core fire protection worldwide, and their problem was not that it cannot control fires. It actually does control fires. And when there's a leak of hydrocarbon, the sprinklers actually cool the environment and make sure there's no additional leaks. The problem was, and everybody knows this, if you put water on a hydrocarbon fire, the hydrocarbon fire spreads further away. So the addition of the foam through the sprinklers actually tackled the two things. You got the cooling, you got the extinguishment. It works. We didn't have a lot of information on actual losses caused by a foam system that doesn't work, more than valves that were closed. But it's a great success. And I would say maybe we were a bit too lazy about other alternatives that are available besides foam. But that's how it got installed. Now, what is the scale of the problem? And I'm going to talk about Belgium alone, excluding the fire departments, the fire chiefs of Holland and Antwerp. They've explained how much foam there is in the systems of the fire department. Well, we estimate that you have foam systems in warehousing in Belgium and the rest of the world, in printing plants, in thermal oil systems, food plants, aircraft hangars, high challenge locations. We believe that much more than 1,000 locations in Belgium alone have these foams in their systems, PFAS foams. So the scale is quite big. What happens if you don't control the small pool fire in the beginning? Well, a pool fire might just be the beginning of the problem. In the photo that you see here, there's a major pool fire underneath some spheric tanks. They could explode. So a timely control of a pool fire is very vital. If you can control the pool fire, most of the damage is prevented. So is foam addition the only solution to control a pool fire? And my previous presenter, Philip, already made the allusion to alternatives. Yes, there are alternatives. This is a normal setup of a foam concentrate system. So foam concentrate injected into the fire sprinklers. And if you check the data sheets, and this is why I mentioned the FM Global data sheets in the beginning, if you check the data sheets, then you will find other solutions to the same challenge. For instance, the first one, drainage. I know a couple of sites here in the harbor of Antwerp, and I know they're listening. They have actually big, powerful drainage systems. It costs a lot of money if you need to renovate it, but it actually works, because what it does is you always assume that your initial leak will not be a catastrophic 10,000 liter per minute leak. No, it will be a relatively small leak, 100 liters per minute. If you don't act quickly, it will become 10,000 liters a minute. So the way it works is you send a lot of water, 5,000 liters per minute, onto the fire. You take away as well the fire, and you drain it towards a catch basin. It's great, you would say, in an existing situation. During a fire, we're not expecting the fire department to dig holes in the ground to drain everything away. So this is something that has to be installed by the locations themselves. But it does work. Another solution, maybe even a bigger priority than the first one, is reduce the amount of leak potential, limit the spill potential. So in a way that, and everybody who is in the fire brigade here behind the screen, if you have a pool fire with only 1,000 liter, you wait a couple of minutes and the fire is done. Limit the spill potential. That's a great alternative. Another alternative, which only works with liquids that can be solved in water, is to increase the density of the sprinklers without foam to such a level that you will just soak the solvent that is leaking, and it has no flashpoint anymore because the vapor pressure is too low to develop or sustain fire. It's a possibility. And the fourth one is to apply, in addition to the sprinkler system, so apply a gaseous extinguisher system or water mist. The downside of these methods is that it's limited to a certain compartment size. But you got 4 alternatives to foam. I want to reiterate something that happened in Moerdijk. This is not the Rotterdam Fire Department area. It's from Moerdijk. I wanted to make sure that is correct. But if you use the correct container size or the container style, you also don't need foam, because your pool fire is going to be limited. If you continue to use plastic IBCs, you have massive fire potential. And what we have seen at the big fire in Chemiepak, even foam doesn't work on it. So let's assume you want to buy 3F or F3 foams. You can recognize them by the fancy colors, by the fancy logos, PFAS-free, green. But my question is it really PFAS-free? Probably not. And does it work on fire? I don't know. And that is the main problem with all foams, both AFFFs and the new foams. We don't know if it works. There's a lack of regulation about foams, and this needs to be solved, because you got last fire, you got the EN norm, you got the ICAO, you got Underwriter Limited, and you got FM approved products. Which one is good for my system? And I think I got a couple of recommendations to do, because I think, and this is for people that are in regulatory affairs, there should be a regulation on the information that is distributed about each foam. Number one, I want to see on every piece of paper of a foam which discharge device it works with and which expansion ratio it should be worked with. This is something that Philip before me explained. So will it work on a sprinkler? Will it work on type 1, type 2, or type 3 discharge devices? Currently, there's no fixed statement that is saying that it works with this one. I also want to see which is the real viscosity and what is the proportioning ratio, because it depends what kind of foam proportion I can put behind it. Can I still use my existing one, or do I need to invest in a new one? The third one is, to which solvent or test fluid has it been tested? I've spoken to the people from the fire department here. They've done extensive testing of various foams just to make sure that the foam that they have works. But is this something that a client should be doing, or is this something that the foam manufacturers should be doing? Because you can have alcohols, MEKs, acetones, naphtha. You have so many different solvents that I want to see it on a piece of paper for what liquid it really works. And what we've seen for the testing is that the terms polar and non-polar are no longer the most determining factors. It is now compatible versus non-compatible. Probably, I also want to know if the foam that is delivered to me works with a specific system. So does it work with a specific proportion or specific discharge devices? The opportunity to act is really now. As a field engineer at FM Global, and also before at FPC Risk, I've seen that sprinkler systems that have been installed for 20, 30 more years, they're getting old, they're getting rusty. The insides are really rusty sometimes. In many cases, it's related to corrosion due to foam that's just getting foam concentrate that just enters the piping and is never flushed. When we do an actual design evaluation, in nearly 50% of the cases, we have to tell our clients it's not going to work because this, and this, and this. There are many factors why it wouldn't work. And then finally, the most expensive test is the proportioner test. And in many cases, it fails. So we've got an existing arsenal of fire protection, stationary systems in Belgium, in the Benelux, in Europe, that needs to be changed. Another reason is, of course, the timing. I think every presenter has indicated that the timing is very tight. We will have a stop of production of AFFF systems by 2025. And And we know that the budget cycle in many companies is always a year behind. If you want to invest something this year or next year, you have to declare it in this year. Now, imagine that by 2025, everybody of those thousands locations in the Benelux would like to change their system. You're probably not going to be one of the happy few that will have the system that you want. So be quick in planning for the CapEx investment. My conclusions are the following. First of all, please have an evaluation of your site. Where are the pool fires? How big can they be? This can be done by your insurance company or by competent engineering companies like FPC Risk, to name one. But it's the first analysis that you need to do. Second one is, do I have alternatives to foam? Because there's going to be a huge cleaning cost already. But do you really want to have foam in the end? Foam, like many of the presenters have said, that the new foams, they're not so liberal when it comes to margin of success. It's very specific, the new foams. It works exactly with this head. It works exactly with this proportioner. We've even seen tests that foam through the same type of orifice. An orifice is the opening of the sprinkler. The same orifice size works in one situation, doesn't work with the other. So it's really fine-tuned. So the alternatives, the 4 alternatives that I explained, you really have to look into them. Third one, when you decide to go to a fluorine-free foam, inform yourself of for what application it is, what proportioner I need, and in the end, is there a certification available? The last option is always still buy AFFF. Still an option, it still works, but, and this is my final point, this is not a sustainable choice. Within a couple of years, it has to disappear anyway. Within a couple of years, it's not produced anymore. So with the last phrase, I will stop my presentation. Resilience is a choice. I thank you very much. Have a nice day.